Hello, my favourite people. We are on episode 3 today. We're talking about money, okay? And I'm going to specifically focus on annuities. But an important one, financial maths is a fair big chunk of the syllabus. Today, again, I'm just going to focus on the pieces of it that come up a fair bit and just some important stuff to know. So let's have a look straight away. Now, this question, it's not something that's going to be asked exactly like this very often. However, the skill in it is very common, especially in basic money questions involving compound interest. Sometimes it can come up in a way in simple interest, and then definitely the skill is used in annuities. So let's have a look. We've got an amount of money invested for 3 years at a certain rate. Now it's invested. So think when something's invested, it's not borrowed, this one's invested. It means that they're putting it in a bank account, okay, and it's earning interest. If it was borrowed, then they've borrowed it from the bank and it would be getting charged interest. Not much different in the maths, but just have that understanding. All right, now, the word compound is in here, and straight away, as soon as I see compound, I'm thinking, okay, my compound formula is that future value equals present value times by 1 plus the rate to the power of n. Okay, otherwise you've sometimes seen as A equals P. They mean the exact same thing. Okay, they just change it to FV, PV for future value, present value. All right, let's have a look. The first one, it says it's compounded yearly. All right, they're really just testing that you know how to put the right values into the formula. If it's compounded yearly, it was given as 3 years, so my number of time periods doesn't change. It's 3 and they've given me 3. But let's keep looking. Your interest charge is 6% per annum. So again, that's given to me as already in per year. And don't forget to change that to a decimal. So now it's just a matter of saying, okay, in the formula, I'm going to have my 8,000. It's charged by my interest to the power of 3. So pretty straightforward. All right, but then what happens if it says it's compounded half yearly? All right, very common. This is where you have to change your rate and your n values. The principal amount of 8,000 will never change. Don't ever change that number. It's the rate and the number of time periods that's going to change. So think, it was 6% per year, so for half a year, it's going to be 3%, which again, put as a decimal. And the number of time periods. So let's think about this. What happens is every half year for 3 years, it earns its interest. So that means after 6 months, the bank goes, okay, here's your interest. The next 6 months, okay, here's your interest. So if they do that every half year for 3 years, they're going to do that in a total of 6 times. So then it's just a matter of putting it into your formula with your new values, okay, and get your answer. All right, let's have a look at monthly. So what's our R and N value? All it's going to be is, okay, well, our rate is 6% per annum. So to find what that will be per month, I could just divide it by 12, which gives me 0.5%. Now be careful, 0.5 is still in a percentage, so then it's going to be 0.005 when you divide through by 100 to get it as a decimal. And n number of time periods, so now every month they give you that. So it's going to be my 3 years, but 12 times each year. So my new n value will be 36. So then you'll do the exact same thing, put in your formula with n 36, r is 0.05. For finally, quarterly, there's a few ways you could do this. Quarterly you could think as 3 months, or what I more prefer is just think about it logically. The rate, if it's 6% for a whole year, we know it's 3% for half a year, so it's going to be 1.5% for a quarter of a year, okay? Alternatively, you could take 0.5, because that was what it was per month, and times that by 3 for 3 months, which is a quarter. Now remember, that needs to be written as a decimal. So the number of times, every quarter of a year. So that's 4 times in 1 year, okay? They do it every quarter. 4 times per year for 3 years gives me an n value of 12. So the last skill, and then you just put in your formula. Just note, what would give you more interest? So remember, this is an investment, so we're talking about earning interest. So if you put all these in your calculator, you'd have a look, well, it's still the same amount of money, it's just being compounded or given more interest more often as we're going along. So thinking about what one's going to be more likely to give you the most interest. Well, it's the more it's compounded, the more often it's compounded, the more interest it's going to earn, okay? Which would be our monthly, because it's compounded 36 times as opposed to the rest, which were smaller numbers. So if they were borrowing money, in real life, if you're borrowing money, you want it compounded as less as possible, because then you're getting charged lesser interest. All right. So investing money, more compounded periods, the better for you. Borrowing money, the less compounding periods, the better for you. So this skill of being able to turn your R and N values, yes, it comes up a lot in compound interest questions, but it also comes up in annuities questions. Okay. The next thing I want to look at just before we do jump to annuities though is rearranging some simple interest and compound interest questions. So let's have a look at our two formulas. One's simple interest, one's compound interest. Always assume it's simple interest unless you see the word compound. Okay? So what can happen is they might say to you, okay, what's the rate that this interest was charged at if it earned this much interest for this long and it was this much money to begin with? So let's think about just simple interest for now. If they ask a rearranging question for what the rate is, remember, it's just a matter of getting R on its own. Think that R is times by the P and the N. So I need to get R on its own. It's like an equation. To get it by itself, I need to get rid of P and N. I'm going to take both P and N to the other side at the same time and think, well, what are they doing? I need to do the opposite on the other side. So P and N are timesing, so I'm going to bring them both over at once and divide. That will give me what the interest rate is, okay? So it can work the other way. If you need to find how long something was invested for, let's say the question said, find how long $200 was invested for at 3% per annum and it earned $60 in interest. So we're rearranging to find N this time. So you're going to do the exact same thing. Okay, so you're just going to take the other two over and divide them, and that will be left with N. So no matter what you need to find, rearranging a simple interest formula is pretty easy. You can either rearrange the formula like I have, or sub the values in and then just rearrange it like an equation, but you'd be doing the same thing. Compound interest may be sometimes a bit harder, but not really. You will never get a question finding N. Okay, that's in advanced maths, and they use logs and exponentials for that. So you'll never have to find N. So let's find PV. In other words, let's make PV the subject. Well, let's think PV is just timesing by this whole lump here, and that will be just a number. So to get PV on its own, I would just have to bring everything over and do the opposite of timesing, which is divide. And now I've got the present value on its own. But what if they said, what about what's R? 1 is just a number 1, so you obviously never have to rearrange for that. We know we can't rearrange for N, so what if they said rearrange for R? Let's think then. We go, okay, I need to get rid of everything one by one. I have to start with the things furthest away. So to get R by itself, the furthest thing away is the PV that's timesing. So I'm going to bring my PV number, whatever the number that is, over and divide it. Then on the right hand side, I'm just left with R passing with 1 to the power of N. The next thing to get rid of would be the N. Now think, that's the same thing as, let's say it was x squared. If we take the square to the other side of an equation, we would square root. If it was cubed, to take cube to the other side, we would cube root. So if it was the power of 8, we take 8 to the other side and 8th root it. So what I'm going to have to do on this side here is nth root it. And it's the whole thing. Now, I've taken away the n, so there's no need for the brackets. So now I'm nearly there. I need R on its own. I'm going to have to take that 1 to the other side and just subtract it. Now be careful, the 1 is just going to be on its own. It's not part of that root. Tough question, but that is what you would do if they asked you to find what the interest rate was on a compounding interest question. But again, if they give you the values, which most likely they would, so the numbers, just plug the numbers in first. Sometimes if the numbers are there rather than all these letters, things can make more sense. Okay, now let's have a look at how we can apply these skills in our annuities question. So if you'd like to have a go at this question, pause the video and see how you go. Otherwise, we'll go through it. All right, the first thing I want to talk about is the main formula. It tells us that Dominique wants to have a future value of 15,000 because she wants to get to that. It's a future value table, so that's the first thing I always check to make sure. If it's not lining up, it's not present value or future value, it means that the question's a bit harder and it might require a few more steps. But let's have a look at this. The main formula we learnt together was this formula here. So the future value, or the value you need to find, is the annuity times by IF. IF stands for the interest factor, which are these weird decimal numbers in the table. So what thing I wanted to just specify is what makes something an annuity. When we went back up here to the compound interest questions, right? These questions here, they just invested one amount of money and they left it in the account, they didn't touch it for 3 more years. These answers that we would get down here is just how much interest was added onto the amount. So it'd be 8,000 plus whatever the interest was. What makes something an annuity rather than just a deposit? An annuity is where, yeah, they might invest the $8,000, but then they make regular contributions. So every month they might invest another $200. That is what makes something an annuity. So it's where there's contributions within the time period. So now, let's look at Dominique. She needs $15,000 in 2 years' time. She invests $3,500 every 6 months at 4% per annum, compounded half yearly. That's the key thing. And notice that's sounds familiar because we just looked at questions where it had what it's compounded as. So let's think. We need what R is and we need what N is. That's the first step. The rate is 4% per annum. If it's compounded half yearly, it's going to be 2% every half yearly. So to show the marker, I wouldn't just write 2%. I would show them what I know the 2% is per half year. And she does this for 2 years. Every 6 months. So every 6 months for 2 years, which means she's going to do that, 4 times, okay, because she's doing it every 6 months for 2 years. All right, so now we have our N value, we have our R value, we can find our interest factor in the table. So we have N is 4, R is 2, and here is our interest factor. All we have to do now is say, okay, will the future value be the annuity, which was $3,500, times by the interest factor? And that will give us what she will have after 2 years in this annuity. Putting it in the calculator, we get $14,427. So what does that mean? It means if she put $3,500 in the account at the start of the 2 years, and then every 6 months she would put another $3,500, it's got this interest rate. She's going to end up with $14,427, which isn't the $15,000. The question isn't finished yet. It says, will she have enough? So you need to say, no, she will not have enough. And blah, 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 blah. She will not have enough. And you could even go to the point and find the difference between them and say she'll be short by $573. What a great way to end the question. Okay, so what do? We start with our formula. Once you have your formula, get your R and your N values. Once you find them, get your interest factor. Once you got them, put it into the formula. All right, let's have a look at the next one. Pause the video here if you want to have a go. This question here was a hard question in HSC a few years ago, okay? It was poorly done by the entire state. So it's meant to be a bit tough. All right, the first one was nice and straightforward. It's only 1 mark, so there shouldn't be too much involved. What would the future value be if they had 5,000 and we had a rate of 3% for 6 years compounded yearly? So I'm thinking, okay, yearly, 6 years, 3% per annum, it's all in the right terms. So here's my R value, here's my N value. You must write that there for the marker to see. Then the markers have actually specified that they want to see that labeling on your table. Generally, if there's part 2 and part 3, I wouldn't draw all over it just so you can still see the numbers, but at least circle the right number there. Because if you've circled the right number there and you accidentally transcribed it down here slightly wrong or read it off the wrong one, you'd still get the full mark there. All right, so there is our total amount. Okay, part 2, let's have a look at that. This one's a rearranged question. It says, what is the annuity that would provide a future value of this for this long? Okay, so now we just sub it into the formula, but rearrange it. So the future value is 407,000. And it needs to equal what our annuity is. Okay, I might call it X instead, do it properly. All right, it says 7 years and 5%. This is where I get a different color. Okay, 7 years and 5%. Per annum, it hasn't mentioned compound is changing its time, so it's not quarterly or anything like that. It's still per annum, it hasn't mentioned otherwise. So I got 5% and N is 7. There's my interest factor. Okay, so, oh, and that should be a decimal point. Now, I just have to rearrange for the equation. What do I get? Once I divide the number over, solve the equation, you should get $50,000. And you can always check this, okay? Just go back the other way, all right? All right, that was only 1 mark. Now we're going up to a 3-mark question, which means I'd look at this and go, okay, there's going to be a bit involved in this. So pause the video, give it a go if you want to. Let's have a look. Okay, so it says $1,000 per quarter, 4% per annum, compounded quarterly. There we go, I'm underlining it. Straight away, let's have a look. My rate is 4%, so that's per year, so 4% would be 2% per half year, so 1% per quarter. Okay, and again, show the marker, because this is where 1 mark lies. It's for 2 years, and it's per quarter, which means it's going to be 8 times the interest is going to be charged. All right, there's a mark. That's one of the mark out of the 3. So you need to write that clearly. All right, now it says, what will be the amount of interest earned? Well, let's see what this annuity becomes. Okay, so I'm going to show the marker that I'm going to find what my annuity is. Again, different color or label it with an arrow, part 3, show them you know how to find your interest factor. 1% and 8. Okay, if you don't have other colors, just put part 3, like that. Okay, let's see what we get. All right, $8,285.70 is our answer for the annuity. So what does that mean? It means that after the 2 years, this is what the amount will become. It wants to know though, what will be the amount of interest earned? Think about this. How much money did so-and-so, what's her name? Doesn't give us a name. How much money did this person put into the annuity? Forget the interest that's being charged. How much money? They put in $1,000 every quarter for 2 years. So they invested, and again, I would show this working. So per quarter for 2 years means 8 times they invested. So they invested a total of $8,000. So $8,000 was invested into the annuity themselves. So therefore, the interest is going to be $8,285.70 minus your $8,000 that they invested. So it's just, that question's not hard if you understand what annuities are and how they work. And again, I'd put a therefore statement and say, therefore, this is how much interest was earned. I'm going to leave it there, okay? Obviously, there is a lot in the financial maths topic and we've only covered a few things, but these few things are important skills, okay? And trust me, in your HSC on Monday, you will use this skill somewhere in it. Just remember to write the formulas, write R values, write N values. Don't just write numbers. Show the marker what that number means and where you got it from, okay? Underline things, put arrows on things. Be as clear as you can. Don't write a line or a number anywhere in your paper without justifying clearly how you got that number or what it means. All right, guys, stay tuned for episode 4.